I'm going to talk about something I did together with Angelos, another work by Columbia. And before I begin, I would like to gratefully acknowledge the work of others which inspired us. Got the Florian Navo, Lian Kim, Martin Herfut, Eric Tiefs, and especially Steve Checkaway. It's a requirement of this session to have him on one of the slides. So there we are. OK, ladies and gentlemen, I'm going to talk about a vulnerability in a television. A television is a very popular device. There are 1.7 billion, that's 10 to the 9 TVs in the world. And about half of them are smart TVs, which are connected somehow to the internet. So a vulnerability in a television is, I think that's pretty significant. However, I think there's even something deeper in this talk, and some of the fundamental ideas, some of the fundamental reasons for these vulnerabilities are going to be very interesting for system designers of other systems which are similar to televisions. So to see that, I'd like to take you back and to the back. This is the back. So a couple of years ago, a genius engineer at Sanyo had a great idea. Why don't we make a television which connects to the internet? I mean, it's a computer anyway, right? So why don't we just connect it to the internet? So it was. An extra jack was added, an internet jack, and thus was born the smart TV. And people were really happy about it. Everybody loved the smart TV. Now, I think most homes with a television and an internet have a smart TV which connects to the internet. So why did people love it? First of all, the users loved it because finally they could choose what to watch instead of the broadcast networks. Advertisers really loved it because when you advertise to somebody on a smart TV, you know much more about this user, so advertisements are much more targeted, focused, and effective. And of course, equipment vendors really love this because here's a new reason to sell your TV. So everybody really loved smart TVs. Who didn't love smart TVs? Broadcast networks. These are the guys who give us the regular TV broadcast. They were really worried because people were stopped watching their programs. And that means that advertising money was going away. And they became very worried, and they thought and thought and thought and thought. And then they had a brilliant idea. Why don't we make a TV which connects to the internet and to the TV at the same time? And thus, after a few false starts, was born the standard called HbbTV. How does HbbTV look like? Here is a mock-up. Of course, this is not a real screenshot. If somebody can't explain to yourself why, please see me offline. OK. So basically, digital TV broadcast could be cable, satellite, whatever. It's a multiplex. So you get a multiplex stream of various data streams. You have the audio in one stream, the video, you have subtitles, you have program guides. So the guys in HBB said, let's have another stream. And this stream is going to be HTML content and some metadata which explains what's going on. So what happens is that when you go to a channel with this additional stream, you have HTML content being rendered on top of the broadcast content. So you can take a little look at the screen. You see this HTML content can overlay the video, the broadcast video. It can also change the size of the broadcast video. It can hide itself altogether. And it can interact with your remote control. You see you have these buttons, colored buttons, numerical buttons. It can also connect, obviously, to the internet. And so this is one very nice application for the World Cup. You can see all sorts of geeky stuff about the game going on. Another application could be polls, could be interactive content, and so on and so forth. So this is HbbTV. It was launched in 2012 in the European market, and slowly it's making its way around the world. Now it's a candidate standard in the US with the necessary changes because the US uses a different over-the-air standard. And guess what? People really, really love this one as well. Users love it because they can get a lot more out of their TV. And I tell you, once you have a TV with this, you feel really silly on a TV without this one, OK? And advertisers, of course, they're ecstatic because now everybody gets targeted ads. Even if you're watching broadcast television, instead of the normal ad break, you get banner ads. And users love it, advertisers love it, the broadcast networks love it because it's incredibly popular. And who doesn't love it? Well, you know, security researchers. We are very hard to please. So So based on the work of a few other researchers, which I listed, we analyzed the HbbTV specification, and we found 3 serious flaws. And I want to stress, this isn't an exploit or a vulnerability in a TV. This is in the standard, OK? You do it officially and perfectly, and you still get these problems. So there are 3 problems. I'll go into them briefly. You can obviously read the paper. So the first problem is there is no user control over the life cycle of an HbbTV application. What does this mean? You go to a channel with HbbTV, immediately your system starts rendering this HbbTV content, which can include JavaScript and so on. There is no indication that a channel contains HBB. There is no indication that the application is running. And the craziest thing, there is no way of shutting it off. There is no button on the remote which can stop this from going on. So this is the first one. Second problem. This one is crazy. So everybody knows what web origin is. Web origin is one of the cornerstones of internet security. What does it mean? Every piece of content which you get from a web server is tagged with its origin, which is the tuple of host, port, and protocol. And if this is a piece of script and it's trying to access an element in the same origin, it can access this element. If it's trying to go outside its origin, it's going to be severely restricted. So what happens if you get a piece of content which isn't coming off an HTTP server somewhere, but it's coming off the broadcast? It doesn't have an origin, which is a very big problem because the web origin concept doesn't work. So the guys behind this protocol thought and thought and thought, and they decided that the content coming over the broadcast should specify its own web origin. OK? So happily understand how mind-bogglingly problematic this is. This basically means that content coming over the broadcast channel can arbitrarily declare that any site on the internet is running, it's the same origin. It can arbitrarily run code on any website on the internet at large. So this is only number 2. And number 3, this is a bit more subtle. But what happens is that, and this is, I think, Matt also referred to, we have a device which is RF on one side, it's broadcast on one side, and it's connected to the internet on the other side. And there are various promises, expectations, which we believe are always true when you go to an HTTP server, and they're not true in RF. And let me give you some examples, OK? An HTTP server, the connection is bidirectional. An HTTP server is unicast. It's a one-to-one connection. An HTTP server has an IP address and a DNS entry. So if it's going and causing you trouble, perhaps you can mark it or tag it or protect yourself against it or even prosecute the web owners. Now, if you're going over RF, it's unicast. It's unidirectional. And it's broadcast. I can transmit to a lot of devices with a single transmitter. And finally, it does not require any infrastructure whatsoever, any registration. You just find a roof and an antenna, and you're out there. So what happens when you connect the internet with its expectations to RF? All sorts of things start breaking. So each one of these in itself is a very serious flaw. Now, if you connect all 3 of them together, you start getting into real problems. So now let's talk about attacks, OK? We want to talk about attacks. So before I talk about attacks, this is the most boring slide in this presentation, even more than the back of the TV. There are 2 things you want to say about attacks. First of all, what is the attack surface? Am I going to attack a TV? What can I do? That doesn't sound so impressive. What can I do? Change channels? Mute? What can I do on a TV? That doesn't sound very expensive. And the other thing is this attack cost effective? If I'm going to claim that somebody is going to go out there and start hacking, I need to show that the effort involved in times of skill and equipment and risk is less than the risk, less than the gain you're expected to make out of this attack. So let's address 2 of them. Let's first of all talk about the attack surface. And to talk about that, let's go underwater. And let's see our heroes here. So here, if you don't have kids, this is a very famous restaurant, sadly not kosher, called the Krusty Krab. Now, if you stay for tomorrow's cryptography session, the guy who works there as a cook is very big in cryptography. I promise you'll be at least on one more slide. And this guy here is called Sheldon Plankton. And he is operating a competitive a restaurant which competes with a Krusty Krab called the Muck Bucket, something like that, some sort of bucket. And he has a really big problem. It's like one of the leitmotifs of SpongeBob, that he really can't get people to go to his restaurant. And one of the real reasons for that is that the Krusty Krab has the really good ratings on the restaurant site, Kelp. So Mr. Plankton has devised the following attack on this episode. He's going to get his restaurant out there. And he's going to do the following. He's going to write the following piece of JavaScript code. This piece of JavaScript code goes to kelp.com and logs in. If it doesn't log in, it creates a user. If there's a CAPTCHA, it sends it offshore to a CAPTCHA farm. And then it writes using NLP a very critical review of the Krusty Krab, and then it uploads it to Kelp. Okay? Can you write this script in JavaScript? In theory, yes, but in practice, it won't work. Why won't it work? Because same origin, right? The only way you can write JavaScript which will actually interact with kelp.com and fill in forms and so on, is if you're running in the same origin as kelp.com. Do you see what I'm aiming at here? So this is the script. He wrote it. And now Mr. Sheldon Plankton is going to go to a place where there are a lot of televisions under the sea, and he's going to transmit this JavaScript. And what happens is that as soon as these TVs pick up this transmission, they are going to do whatever this JavaScript says. So they're going to go to kelp.com, and then finally somebody will go to Sheldon's restaurant. So this is the attack. Why does it work? Why would it work? So let's see now how all three problems in the specification work together. So first of all, no control over life cycle. This means that as long as the TV is turned on and the guys are watching TV, they will participate in the attack. There is no indication that it's running, and they don't even care that it's running because they still gather audio and video. First problem. Second problem, web origin. The only reason this attack is possible is that the Sheldon Plankton can inject his malicious code into the website he's attacking. And the third one, the fact that we're going off RF, means that without setting up a server or an infrastructure, our attacker can control thousands of devices, even though he's only a single-cell microorganism. So you can see various crazier and more effective, less effective attacks in the paper. You're welcome to read it. So this is the attack surface. So you see, what I want to focus is the title of the paper. We're not attacking the TVs. We are attacking the internet. And another thing you need to ponder here is who is actually under attack here, okay? It's the restaurant. And now you're a restaurant owner, go and look for somebody who's ruining your ratings using this method. Good luck. So this is a very serious problem. Now let's talk about the attack setup, okay? This is the setup we proposed in our paper, and we verified it. You can read it. Basically, this attack addresses DVB terrestrial. That means digital over-the-air transmissions with broadcast antennas. I know that the US has cable and satellite. You're welcome to read the paper to see how we address these delivery methods. So basically what you do, you take a TV channel which everybody is watching, a very popular channel, and what you do, you pick up the channel with a cheap USB tuner, and using your computer, you add the metadata and the malicious application to the multiplex stream, and then you modulate it back into the RF frequency, and using an amplifier and an antenna, you transmit it, and since your signal is stronger than the signal of the radio tower, you're going to overwhelm the radio tower, and the guys under attack will receive your signal instead of the original signal. So the cost of this setup are largely determined by the two pieces here, the DVB modulator and the power amplifier. The DVB tuner is something really cheap. You can buy them for like $10 off eBay, and you get a free antenna. The DVB modulator, when I started doing this research, cost $1,500. Now you can get one from Hong Kong for $180. And the power amplifier, that's up to you to trade off. The more expensive they are, the higher power they are, the more cumbersome they are. So let's assume you want a 1-watt transmitter. That costs you around $200. So with all the cabling and so on, this is going to cost you about $450. Using this specific mix of power amplifier And modulator, you can cover an area about 700 meters in diameter. So let's kind of put this on a map. I did some research, and I found an area in Manhattan. And this circle is it's a very nice place. In this location, it's possible to attack Univision, Telemundo, CBS, Fox, and NBC. And this is based on real signal strength measurements. And the population inside this circle is between 60 and 80,000 people. So $450, 60 to 80,000 people. So this attack is cost effective. OK, what next? We're engineers. We want to solve stuff. Let's talk about countermeasures. So there are 3 flaws. And each one of them can be solved. OK, you want to control the fact there's no control over life cycle. Duh, give them control over life cycle. There's a beautiful example, the HTML5 full screen API. So we actually had some slides with the HTML5 warnings on the top yesterday. You want to run content? Ask me for permission. I give you permission. Next time you go to the channel, give me a little, just you should know, FYI, there's content running here. The implementation of web origin can be solved. There are brutal ways of saying, nobody can access anything. There are more, subtle ways of signing and certification and PKI. You can do that. And the third thing, you will have to think very seriously, and this is like systems thinking. How do you connect RF source programs to the internet? And my view of it is that you don't. If you're coming over broadcast, stay in the broadcast domain. You want GIFs, you want scripts, you give it all on this broadcast. There is no reason for you to go to the internet. And because if you're connected to the internet anyway, just fetch everything for the internet. So these are all countermeasures. I put them in the paper. And the problem is that all of these countermeasures are bad for business. What does this mean? There are HBB applications out there right now for business reasons, which actually make use of the design properties of the existing protocol. For example, there are people meters, which are basically invisible cookies which phone home once in a couple of seconds. And most of the German channels, Eric Taves did a lot of research about this. I think he's here. They phone home once in a while, and they're used for tracking. And if I would suddenly ask people for permission, then this business won't work, and so on and so forth. So this really calls back to what Phil talked about yesterday. So there is a business reason not to fix this, and I'm very pessimistic. So this is about the TV. So now let's talk about the big picture. So what makes these attacks possible? And if you take a look at the flaws, about the problems, none of them are really specifically addressing televisions. There's nothing about television. All of these flaws are made possible because you have a device which is a sensor, in this case a very sensitive sensor, which is connected to the internet. And now we're going to have more and more of these sensors. We're going to have health sensors, weather sensors, toaster sensors, and so on and so forth. And as system designers, we really need to think about what do we do with these new challenges. How can we make these systems more secure? Not just TVs, but anything on the Internet of Things. And another interesting idea is, can the fact that all of these devices have a cloud side, which kind of crowdsourced knowledge and maybe distributed algorithms sorts, maybe that can kind of help us make these devices more secure. So with that, I thank you. And if we have time for questions, I'm welcome to them.
All right, thank you. So if you have any questions, we've got a mic over there and a mic over here.
Shuo Chen, Microsoft Research. So very interesting work.
Thank you.
My question is, if I understand correctly, you can only post anonymous reviews on the website, right? Because I don't see how you can automatically log into accounts.
OK, so this is kind of, to answer this, I have to say, I said that this attack is working on a fully secure television. So televisions today, smart TVs, have this capability of doing HBB, and they also have web browsers, and they have web apps and widgets and so on and so forth. So if the user of this television has, for some reason, logged on to Yelp for some other reason, he will have a user credential or a cookie or something stored on his television. If the television is not designed to protect against this, these credentials may be used by the HbbTV application. And another thing, there is nothing stopping the user from the attacker from creating a user for this sort of attack. Okay?
But if he's able to do that, then the entire attack can be done by himself, right? You don't have to
Yes, but the scale.
get onto the TVs.
Yes, but the scale. You have tens of thousands of devices, pristine devices, never used for any attack, fully patched. Wonderful. Okay?
Thank you.
Yossef?
So your example of the people meter that dials home to say, hey, I'm watching this is kind of disturbing. We're all familiar with the European Union's interesting policy on cookies.
Mm-hmm.
Is this, like, are any regulators even vaguely caring about this? I mean, that seems very applicable in this case.
Okay, so in this conference, there is somebody called Eric Teves, and he might raise his hand if he hears me. And he actually did a lot of interesting research about the privacy implications of HBB. And I think there is a concern in the European Union about this stuff going on. Okay, but this is not what I'm covering in this work.
A quick question. Can you combine the results of this paper with the previous paper such that the smart TV will actually record you, because some smart TVs have Skype, and then you can have, you know,
Yes.
the TV watching after you, just like in 1984.
Thank you, Or. That's a very good statement, and it's a very good concern. So one of the things we noted is that smart TVs, being computers, have a lot of open source components of various ages and pedigrees. And if I were to find an exploit for one of these devices, for one of these open source libraries, and spread it out using HBB, I would have a very effective way of spreading an exploit. And once I have root, I can do whatever I want. For example, turn on the television. So yes, that's a very correct statement. It's one of the problems with the specification. Anything else?
All right, thank you very much.